Venturimeter. See, we have derived the equation of Bernoulli's equation, and now this is Venturimeter. Basically, Venturimeter is a device which is help in using for measurement of rate of flow. Rate of flow, that is discharge in a pipeline. Okay. This works on the basically the principle of Bernoulli's equation, and there are three types of venturimeters. One is horizontal, vertical, and the last is inclined. Okay. And basically I may draw the diagram of venturimeter. Venturimeter is something like this. It have a sharp converging and a throat and then diverging part. Okay, so this is the throat, this is the converging, this is the diverging. Okay, and here is the manometer which is attached in the throat section as well as in the converging section. This is the inlet section and this is the throat. So this is a simple venturimeter, and here is the liquid or fluid flows through the venturimeter, the pressure head, and you can say like this. This is the direction of flow, and here is the difference between this is H. The two levels in the meter is H. So venturimeter had three parts: converging, throat, and third is diverging. Now the converging, the throat, and the diverging part. Now we have this venturimeter. Now let's derive an equation for the discharge in venturimeter. So this is diameter d1, and I may write like this: d1 is the diameter of inlet. This is section 1, this is section 2. Okay, in the section 1, d1 is the diameter of section 1, p1 is the pressure at section 1, v1 is the velocity at section 1, a1 is the area at section 1. Similarly, d2, p2, v2 and a2, diameter, pressure, velocity and area of section 2. Now we have to apply the Bernoulli's equation. Bernoulli's equation states that P by rho g plus V by 2g plus Z equals to constant. So P1 V1 Z1 equals to P2 by rho g plus V2 by rho 2g plus Z2. Okay, and as this is an horizontal, we can see as by the diagram. So Z1 equals to Z2, this get cancelled out, and we may bring the P in one side, then P1 minus P2 by rho g equals to, this is square, and V2 square minus V1 square by 2g. And now we know that P1 minus P2 by rho g is the difference in pressure head. That is the difference in pressure head now section 1 and 2, and this is equal to H. This implies that V2 square minus V1 square by 2g is also equals to H. Now we have to deal with the discharge. Basically, discharge is equals to area into velocity. So for here section 1 and 2, this will be the discharge. Now from this equation we get V1 equals to Q by A1 and V2 equals to Q by A2. अब ये जो वैल्यूज आई हैं V1 और V2 की, अब इसे हम यहाँ पुट करेंगे तो कुछ ऐसा मिलेगा। अब इसको सॉल्व करेंगे, कुछ इस तरीके की इक्वेशन हमें मिलेगी। Q equals to A1 A2 अंडर रूट A1 स्क्वायर माइनस A2 स्क्वायर 2GH। यहाँ से Q कॉमन निकालेंगे, इनको सॉल्व करेंगे। यहाँ नाउ ये होता है थियोरेटिकल डिस्चार्ज। अब हमको थियोरेटिकल डिस्चार्ज निकालने के बाद एक्चुअल डिस्चार्ज निकालना पड़ता है, यानी कि इस वेंचुरीमीटर से कितना एक्चुअल डिस्चार्ज हो रहा है। So the actual discharge, there is a requirement of a constant that is known as CD. This is known as coefficient of discharge. And hence the formula is changed to CD A1 A2 2GH upon square minus A2 square, and this value of CD is always less than 1, and there are some of the cases which has to be considered as per the Venturimeter. I may tell it.